Okay, so this is lesson 6.5. The formal title is Interpreting Quadratic Equation Roots, but really this lesson should just be called How Many Zeros, Roots, Solutions. We know that all three of these things mean the same thing, and the whole purpose of this lesson is determining the number of solutions to a quadratic equation. We're not all that interested in what they are. So we won't be using the quadratic formula today. We won't be factoring. What we will be doing is using a tool to determine the number of solutions. So let's start by talking about this. The discriminant. Okay, the discriminant comes from the quadratic formula. So I'm just going to write the whole thing out. We know that the quadratic formula, okay, is minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that entire thing is the quadratic formula that is used to solve a quadratic equation. This can be used to solve quadratic equations that both can and cannot be factored. However, hopefully in the completion of homework, you've determined that it is far less cumbersome to factor than use the quadratic formula. Unfortunately, we can't always factor. And so I've mentioned this in a previous video. If the instructions say round to the nearest hundredth, that's a pretty strong indication that I gave you an equation that cannot be factored, and so you would use the quadratic formula. All right, so this would be used to determine the value of x that satisfies an equation, and I'm going to go ahead and use the equation from 1a in your note. So this is a quadratic equation. This is in standard form, okay? And so if I wanted to solve this, I could either try to factor it or use the quadratic formula. But what if I wasn't interested in solving it? What if I just wanted to know how many solutions, how many values of x will satisfy this equation? And there are three possibilities. There could be no solutions, one solution, or two solutions, okay? And so the way I would go about doing that is I would use the discriminant. So if I just kind of get rid of some of the quadratic formula here, I am left with the discriminant, okay? The discriminant is b squared minus 4ac. A very commonly made mistake is that kids think they have to square root that. You do not. That alone is the discriminant. And so if we take a quadratic equation, like the example in 1a, and we pull out our a, b, and c values, we can plug those into this formula to determine the number of solutions or roots to the equation. So I'm going to go ahead and do that. I'm going to replace the variables in the discriminant with brackets. Okay, so b is 5, a is 6, and c is 12. And we're going to go ahead and compute or calculate the value of the discriminant. In this case, it is negative 263. Okay, now this means that there are no solutions, no roots, no values of x that would satisfy that equation. Okay, this actually makes perfect sense. If you remember a second ago, I said that the discriminant is found inside of the square root sign. So if the discriminant is a negative number, we can't take the square root of a negative number, so there will be no solutions. And that brings me to this chart from the teacher copy and student copy of the note. So if the discriminant is a negative number, we have no solutions, as we just saw. If the discriminant is 0, we have one solution or root or x-intercept or whatever you want to call it. And if the discriminant is positive, then we have two roots, two solutions, etc. And again, from experience, I feel like when you try to memorize a chart like this, you're likely to make careless errors. So you just have to think the discriminant comes from the square root sign of the quadratic formula. It can't be negative. If it works out to be a negative number, that means there are no solutions. If it's 0, there is one solution. And if it is positive, there are two solutions. So I've just done 1a from the note for you. Let's go ahead and do 1b together. This is the quadratic equation given to you in example 1b. Okay, and we know that we can't do, we know that we can't do anything with that quite yet because it doesn't equal 0. So I'm going to go ahead and we could do this one of two ways. We could bring 3 terms to the right side of the equation or 2 terms to the left. I think I'm going to bring these guys over. So I have a 12 minus 5x already there, and then I'll have a plus x squared minus 3x equals 0. And now I just have to collect like terms and put that in the correct order. So we have x squared minus 8x plus 12. And if you have the teacher copy of the note in front of you, in the teacher copy, I happen to have brought those terms to this side. And so these guys were all opposite signs. It doesn't matter, okay? You'll get the same answer whether or not you bring all the terms to the left or to the right. We just have to make sure that the equation equals 0, and it does. Okay, now, again, they didn't want us to solve this. They wanted us to determine the number of real solutions, which means find the discriminant, okay? So my A value is 1, my B value is -8, and my C value is 12. I'm going to plug those values into the discriminant. Okay, so B is -8, A is 1, and C is 12. I'm going to switch to red because this is a very commonly made mistake. Don't forget, folks, you're not just squaring 8, you're squaring -8. And so when we square a negative, that becomes positive. So that's 64, okay, minus, what does this work out to be? 48. And this happens to be 16, okay? Now, if I asked you to write a two-part sentence, you would say, since b squared minus 4ac is greater than 0, therefore, two solutions. There are two solutions. I'm just kind of using shorthand to save room. Okay? Okay, the next two examples are a bit of a throwback to Unit 5, and I distinctly remember answering a question on EDSB from a student, Miss, how do you know how many zeros there are in the quadratic relation from vertex form? So in 2A, that's exactly what you're given, a quadratic relation in vertex form. I'm going to do a nice little throwback of the transformations so we can review. Reflection in the x-axis, vertical stretch by a factor of 2, horizontal translation 5 units to the right, vertical translation 8 units down, okay? What I've seen students do is expand and simplify, so multiply this bracket by itself, then distribute the -2, and then collect like terms with -8 to get it to standard form, and then from standard form they can find the discriminant. Waste of time, okay? I have been known to give a test question that says determine the number of zeros using 2 different methods. So in that case, that would be acceptable. But if I gave you something like this, we wouldn't need the discriminant. We would sketch ourselves a really simple diagram, and that would tell us how many zeros there are. So the vertex here, and again, this is why it's nice that we did that little throwback to Unit 5. The vertex is -5, -8. So that would be there-ish. This guy opens down. No discriminant, no calculating, no zeros. I can just see by my simple sketch. And this would suffice on a test or quiz. Okay, let's do another example. In part B, you're given a quadratic relation, again, in vertex form. Okay, and we have to determine the number of zeros. So I'm just going to produce a simple sketch. Here, the x value of the vertex is 7, because when we're in the brackets, we're being lied to. And then there's nothing out here, which means the y value of the vertex is 0. This guy opens up, and now it's very obvious to me there is 1 0, 1 root, 1 value, one x-intercept in this particular relation. Okay, so if you're given a quadratic relation in standard form and you're asked to determine the number of roots, you would use the discriminant. However, if you're given a quadratic relation in vertex form, it would be much more efficient just to sketch a quick little diagram as I did here. Okay, and I'm confident that you know what these parabolas will look like because you did so well in Unit 5. You basically just have to figure out where's the vertex, does it open up or down, and then look at your sketch. All right, so now let's move on to number 3. In number 3, it says, without graphing this time, determine the number of zeros in each relation. So here, very straightforward, we are given another quadratic relation in Standard form, okay? I am going to identify my A, B, and C value and plug those values into the formula for the discriminant. Okay, A is -2, C is -7, and B is 3. Okay, and on an assessment, folks, I don't need to see this work. I want to see you plug the numbers in, and then you can take me right to the final answer. However, you should be trying this at home to make sure that you're getting these answers. If not, we need to figure out why. Okay, now, once again, I can write my two-part concluding sentence. Since, right, it's just an upside down triangle of dots. Since b squared minus 4ac is less than 0, or if you'd prefer to say, folks, you could just say since the discriminant is negative, right? Think about it. Where does the discriminant go? Inside the square root sign. If we end up with a negative value, we're not going to be able to finish the question. So therefore, there are no zeros. All right. So at this point, we've done examples of quadratic relations and equations from vertex form and standard form. Now the example in 3b is a little different. We haven't done one like this yet. In 3b, you are given a quadratic relation in factored form and asked to determine the number of zeros. Again, I have seen students convert this to standard form and then find the discriminant. That's not wrong, it's just not efficient. Right from here, I can see that if I were to set the factors equal to 0 and solve, there would be 2 zeros, okay? So I don't have to do any work here. 2 zeros, I can tell because there are 2 factors. Okay, the next question is kind of interesting. It says, determine whether the vertex of this parabola lies above, below, or on the x-axis, okay? And so, yes, we could go ahead and find the vertex, but given that this lesson is about the discriminant, sorry, I'll adjust this, I would rather use that new tool that I have in my quadratic arsenal to solve this question. So let's go ahead in the spirit of this lesson and find the discriminant. So b squared minus 4ac, b is -4. Again, be careful when you're squaring this, you're going to end up with 16. That's a very commonly made mistake. It's not -16. And this works out to be what? Oh, Nelly. Okay, well, we have a, okay, so I just copied the question wrong. That's embarrassing. This is positive and this is positive. That makes a lot more sense. This works out to be 12, right? Because we have what? Yep. And the discriminant is 4. Okay, so I crunched some numbers. I found the discriminant. So I know that this has 2 zeros. And I know that because the discriminant is a positive number. Okay, I don't care what the zeros are. I'm just interested in how many exist. So this quadratic relation has 2 zeros. Okay, so let's think about this parabola for a sec. Okay, it has 2 zeros, and based on this guy and another throwback all the way to unit 3, this parabola opens up. So in order for this to exist, in order for the parabola to open up and also have 2 zeros, the vertex couldn't possibly be over here, because if it opened up, okay, it wouldn't have any zeros. If the vertex was lying on the x-axis and opened it up, again, 1 0. So in order to answer the question, the vertex must lie below the x-axis so that it will have an a value of 2, a minimum optimum value, but still 2 possible zeros, okay? That's a very key word in this particular lesson and something to look for on your assessments, right? If possible. So I just kind of want to go through this verbally, and I hope you're actually watching the entire video. Let's say you get a test question where they give you a quadratic relation that models the profits of a company, okay? So, you know, I'm always selling math kits of some sort. Miss Kerr sells math kits, and her profits are modeled by the relation, and again, I'm making this up off the cuff, but if it says, is it possible for Mrs. Kerr to earn a profit of $300? I don't want to know the selling price that's going to get me to that profit. I just want to know, okay, again, keyword here, if possible. So that would mean throw a 300 into here, make one side of the equation equal to 0, and find the discriminant, okay? If the discriminant ended up being a positive number, yes, it is possible for me to attain that profit. If the discriminant ended up being 0, yes, it still is possible for me to attain that profit. However, if the discriminant ended up being a negative number, no. It would be nearly impossible for me to, or not nearly, it would be impossible for me to earn that profit. And again, for those of you that are visual like myself, right? Let's say we have a relation where we're looking at my profit and the selling price of the product. Okay, and so we know that, this whole unit on quadratics, okay, it's modeled by a parabolic arch like that, where this represents my max profit. So let's say the question said, is it possible for Mrs. Kerr to earn a profit of $1,000? Okay, you would get a positive discriminant, because yes, it is possible. It'd be possible if I sold the product for that much, and it'd be possible if I sold the product for that much. However, if it said, would it be possible for Mrs. Kerr to earn a profit of, $7,000, this would be an example where you would get a negative discriminant because the parabola is never going to hit that point. Okay, so just in case you wanted to understand what this looks like visually. All right, the last example, there's quite a bit going on, and you will get a question like this in the homework, so I definitely want to go through one with you in this lesson. So here it gives us a quadratic relation, again, in standard form. And it says, for which values of y will this quadratic equation have no solutions? Okay, and so again, this doesn't look like an equation right now, so we need to, it looks like a relation. We're going to go ahead and make this equal to 0 by bringing this guy over. So we have 0 is equal to 4x squared plus 24x minus 5 minus y. Okay, and so what they're saying is, here's a quadratic equation, okay? It's going to have no solutions, and so we have to solve for the value of y that will make that true, okay? Again, in the spirit of the lesson, we're talking about finding the discriminant. In order to find the discriminant, okay, I need my a, b, and c values. So a is whatever the coefficient of x squared is. In this case, a is 4. B is whatever the coefficient of x is. In this case, it's 24. Now, this is the part that might seem a little funky, but stay with me here. Oh, that should have said B, I'm sorry. Oopsie. Okay, now C, we would think C is -5, but C is this big whole honk of stuff. That is your C value. And so now we have an A, B, and a C. We're going to go ahead and plug those values into the formula for the discriminant. Okay, so the discriminant is b squared minus 4ac. B is 24. A is 4. C is all this. Okay, and now we just have to be really careful. So 24 squared is 576. Here, I'm going to multiply these guys together. I get -16, and then I'm going to have to distribute that -16 into this bracket. So I get 576. You can't see this, can you? Oh, you can. That's good. Plus 80 plus 16y. We want to be really careful with signs. And now we're going to go ahead and collect like terms. So 656 plus 16y is the value of the discriminant. Okay? Now, the question says that this equation has no solutions. And so, if you like to think of this in terms of a little number line here, okay, when we talk about the, how many times in, 20 minutes can I say discriminant? When we talk about the discriminant, okay, if the discriminant is 0, we have no solutions. That's a lie. If the discriminant is, 0, we have no solutions. That's correct. If the discriminant is positive, we have 2 solutions. Oh my gosh, you guys. I'm going to blame this on my husband who's watching a throwback Utah Jazz Bulls game in the background here because I've just made the same mistake a bunch of times and it's embarrassing. Okay, and then if the discriminant is negative, we have no solutions. I apologize. Okay, so a while back, we found that this was the value of the discriminant. It was 656 plus 16y, okay? So what we're gonna do is we're gonna set that equal to 0 to find out when this equation will have one solution. So you come over here. Okay, so when y is equal to negative 41, this equation has one solution. Again, I thought I made this clear a minute ago, but I was confusing myself. Here we go. Now, they don't want to know when the equation has one solution. They want to know when the equation has no solutions. So it must be everything less than negative 41. Okay, so when y is less than negative 41, therefore there are no solutions. Can you see this? Yes, you can. All right. Hopefully I didn't confuse you too much with this last little segment of the video. Make sure you work on the assigned homework, and there are some really good daily drills where you can practice just the skill of finding the discriminant. Again, the key words with this lesson are if possible. So if you see something that says, is it possible for the ball to reach a height of 100 feet? Is it possible for the company to minimize their cost to a level of $1,400, etc.? That means they don't want you to actually solve the equation. They want you to determine how many solutions are possible. And good luck.